left off with differential equations and slope fields. So we have 2 more examples in this section, and then we're going to do a couple from your homework, and then we're going to move on to the next section, which is more differential equations. So this is a pretty important section. It's always on the AP test. So what we're going to do is we're going over it today, we're going over it on Thursday, and then you're going to have a quiz on it on Friday. So slope fields and differential equations. I would be paying attention. All right, so the first one, it says find an equation of the curve that passes through the point 0, 1 and whose slope at xy is xy. So when we say that the slope is xy, what that's saying is that dy over dx is equal to x times y. So all of the equations that you're going to have are going to be separable differential equations. So you can separate the x's and y's. So we're going to separate, and we're going to have x dx, and then I'm going to have 1 over y dy. I've now separated my variables. So I can solve for y by integrating. Okay. So when I integrate, I get natural log of the absolute value of y equals 1/2 x squared plus c. So you can put a c on both sides. I usually just put it on one side. All right, once we have integrated and we have a plus c, that's when we find what c is. We find it by using the initial condition, which is 0, 1. So we plug in a 0 for x and 1 for y. So we have natural log of 1 equals 1/2 0 squared plus c. So we get c is equal to 0. How nice. So we go back to our natural log of y equation, so natural log of absolute value of y, and we plug in that c value, which in this case was 0. So the natural log of the absolute value of y equals 1/2 x squared. And we want to solve for y. Okay, so we're going to do that by doing e raised to both sides. So you could put like a little e here, and you could say, oh, e to this equals all of this, just like we did in Algebra 2. That's fine. I kind of shortcut it. I do e raised to both sides like that. Because I know an e and a natural log will cancel, and I'll be left with absolute value of y equals e to the, I'll write x squared over 2. Kind of combine it a little bit. Do you remember how to get rid of the absolute value? Yeah, plus or minus. So I have plus or minus e to the x squared over 2. Okay, now you think about the point again. So when you plug in 0 for x, you want to get positive 1 for y. So you make a decision. So it has to be the positive one, right? So we're going to have y equals e to the x squared over 2 is our answer. Now, at any point along the way, if we had domain or even range issues, we should probably write restrictions. Okay, and we did. We had natural log of the absolute value of y. So we know that y has to either be greater than 0 or less than 0. We can't have 2 branches. Remember, we can't have like 2 curves through a differential equation. We talked about that yesterday. So we have 2 choices. We can do y is greater than 0, or we can do y is less than 0. Okay, look at your y value on your initial point. Right, y is greater than 0, right? So we're going to do y is greater than 0. So just somewhere next to this part, I would write very tiny y is greater than 0. Did we have any issues with x? No, so we're good with x. All right, so the next one, so it says solve for y if dy over dx equals e to the x minus 2y. Okay, this is a pretty difficult one, right? There's not really, like, how do you separate those variables? It's tricky. Okay, so what we do is we use our laws of exponents. So remember exponent rules, if I had x to the 5th, or x to the 5 minus 2, that's really x to the 5th over x squared, right? Okay, we're using that rule. Okay, so we have e raised to something that's subtracted. So I'm going to write it as e to the x over e to the 2y. And I'm going to separate. So I'm going to do e to the 2y dy equals e to the x dx. So when I integrate, can you guys do e to the 2y quickly in your head without a u substitution? E to the 2y over 2, right? 1/2 e to the 2y. Because you would gain a 1/2 from the u substitution. So we get e to the x plus c. And we plug in natural log of 2 for x and 0 for y. So I'm going to have e to the natural log of 2. And then I have 1/2 e to the 2 times 0. So e to the natural log of 2, do we know what that is? They cancel, right? It's 2. Got to remember all these rules from Algebra 2 and Pre-Calc. We did it in Pre-Calc too. All right, and this side becomes e to the 0, which is 1, times 1/2. So our c value is going to be 1/2 minus 2, which is negative 3/2. So we put that all back in. So we have 1/2 e to the 2y equals e to the x minus 3/2. I plug in my c. All right. And I want to solve for y, so the first thing I'm going to do is I'm going to multiply by 2 on both sides. So when I do that, I get e to the 2y equals 2 e to the x minus 3. Okay, and we want to solve for y, so we're going to take the natural log of both sides. So we're going to have natural log and e cancel, so I get 2y equals natural log of parentheses 2 e to the x minus 3. And as much as we want to like break that apart into separate natural logs, a lot of people will say natural log of 2 e to the x minus natural log of 3. We can't do that, right? The rule was if you had natural log of a divided by b, that made subtraction. Natural log of a minus natural log of b. But we didn't have anything for natural log of a minus b. That didn't like go with division or anything. Does that make sense? All right, so we can't do anything with that, natural log of a minus b. So we divide by 2. So our answer is going to be 1/2 natural log of 2 e to the x minus 3. And you can leave it like that. Okay, usually these are free response questions. You don't really have to think about the different forms, like they would accept that form. But I do want to mention that we might also see, right? Did you see what I did there? I brought the 1/2 up as a power, so you might see that. Okay, usually these are free response questions, so not multiple choice, unless they're super simple on the multiple choice. Okay, so you had a couple on your homework that I want to talk about. So the first one that people asked me about was number 3. So I told you to kind of start these problems out. I told you they were kind of difficult, and we would see if you needed help. So we have that. All right, so when I separate, I'm going to have 1 over x plus 3 dx, and then I'm going to have 1 over 4y dy. Okay, now some people came to me and they kind of went a complicated way, which is fine. Like they integrated 1 over 4y using a u substitution. So they had 1/4 natural log of 4y, right? Which is totally fine. It just makes it a lot more complicated than it needs to be. So what I recommend is if you have something like 1 over 4y, 1 over 2y, something like that, you think about it this way. 1 over 4, and then you integrate the 1 over y part. Does that make sense? Because really, 1 over 4y is really 1/4 times 1 over y, right? 1 over 4y, same thing. And it makes it a little bit nicer. You do get the same answer in the end. It's just more a roundabout way. All right, so here we go. So as I integrate, I get 1 over 4. I'm going to have the natural log of the absolute value of y. And then I would do like a u substitution here. So you can write the steps. U equals x plus 3. Du is then dx. You'd have 1 over u du, right? So we know that it's going to be the natural log of the absolute value of x plus 3 plus c. But be careful with that. A lot of people just assume whenever it's 1 over whatever, it's going to be natural log. Think about these things. Is that natural log of square root of x? No, it's not, right? You would write it as x to the negative 1/2. You can't just like always do that. Same with things like this. If you have a number out front, think about the u substitution. If u was equal to 3x minus 4, you would gain a 1/3 out front. You'd have 1/3 du. Does that make sense? So be very, very careful. Don't just assume that everything that's 1 over is going to be like involving a natural log. All right, anyway, so we continue on. So the point that you were given was that y of negative 2 was equal to 1. So if I plug in negative 2 for x, I get a 1 for y. That was very nice of me. So natural log of 1 is 0, so I get 0 equals natural log of 1, which is 0 plus c. So c ends up being 0. So if you had done this a different way, like if you hadn't pulled out the 1/4, or if you had left the 4 up here, right, your C value might be different than your friend's C value. So don't be confused if your C's are different. Like you might have solved it differently and you'll get the same answer. All right, so we go back in and we plug it in. So we have 1/4 natural log of absolute value of y equals natural log of the absolute value of x plus 3 plus c. Or not plus c, plus 0, right? So that's gone. Okay, ideally, if you can get it to be natural log of a equals natural log of b, do you guys remember this from Algebra 2? If you get natural log of a number equals natural log of another number, you can say those two numbers are equal. Okay, that would be the best thing in this scenario. Can I do that? Can. I'm going to multiply the 4 over. And when I see that 4 out front, I'll pull it up as a power. So I'm going to have the natural log of the absolute value of y. And I could have done that with the 1/4. It would just be a 4th root, right? Same thing. All right, so I'm going to have natural log of x plus 3 to the 4th. Okay, I got rid of my absolute values. Is that okay? Yeah, it's to the 4th. It doesn't matter, right? So now I can do e raised to both sides, giving me absolute value of y equals natural log of x plus 3 to the 4th. Or sorry, not natural log, x plus 3 to the 4th. So y equals plus or minus x plus 3 to the 4th, and we make that decision. So we say if we have the point -2, 1, we want to be able to plug in a -2 and get positive 1 out. So do we choose plus or minus? Plus. We want y to be positive, right? So our answer is y equals x plus 3 to the 4th. That's a longer one. Anything that we should say about domain or range? How about y? So we had absolute value, natural log of the absolute value of y, so we can't have y equals 0, so we pick one of the two sides. Either y is bigger than 0 or y is less than 0. Based on our point, y is greater than 0, right? Same thing with the x plus 3. Okay, we can't take the natural log of 0, so we have to pick either x is bigger than 3 or x is less than 3. So what do we say? Is x bigger than 3 or less than 3? Or, sorry, x bigger than -3 or x less than -3? That's a little tricky. Greater than -3 or less than -3? Our point is -2. It's bigger. It's x is greater than -3. So that's our final domain. Okay?